Okay, section 2 of chapter 32 is about conservation of charge. So going back to section 1, remember that protons are positive, electrons are negative. Now typically atoms are going to be electrically neutral. Okay, and the reason for that is that usually an atom is going to have the same number of protons as it has electrons. Okay, so for example, if we were to consider the helium atom from section 1, that helium atom has 2 protons in its nucleus, and it has 2 electrons orbiting around the outside. I'm not going to draw the neutrons because remember the neutrons in terms of charge aren't really very important since they are neutral. So, 2 positive charges, 2 negative charges. Remember that a proton and an electron have the same amount of charge, just opposite signs. So the 2 negatives and the 2 positives are going to cancel. Now, sometimes electrons can be lost, sometimes electrons can be gained. So let's look at what is going to happen here. Right now, we have 2 positives and 2 negatives. Positive 2, negative 2, those cancel out and make 0. But let's say that one of these electrons is lost. So this electron is going to go away. Now, we still have the 2 positives, the 2 protons in the nucleus, but now there's only 1 negative, only 1 electron. And so if we have positive 2 and negative 1, we now have an overall charge on that atom, and it's now called an ion. A charged atom is called an ion. It either has lost or gained electrons. So it loses electrons. If we take away a negative, what is left over will be positive. Let's do the opposite now. So we still have our original 2 protons and 2 electrons. But let's say that it were to gain an extra electron. Well, now we have still the 2 protons, the 2 positives, but we have an extra negative. So 3 negative charges. Positive 2 and negative 3 make negative 1. And so now, when it gains an electron, we're going to have a negatively charged ion. Not only can atoms become charged, but so can everyday objects. Okay? So an object can become charged whenever it loses or gains electrons. Some materials are going to lose electrons easily. Other substances are going to not lose electrons easily. Some will gain electrons easily, some will not gain electrons easily. So this little cartoon is showing the gentleman rubbing the rod with a little piece of fur. And fur is really good at donating electrons. So as the friction between the fur and the rod occurs, the electrons are going to move from the fur into the rod. So, what kind of charge will the rod have? Since it's gaining electrons, that rod will now be negatively charged. And the fur, since it is losing electrons, will have a positive charge. Now, notice they're going from the fur to the rod. It's not that the rod is just all of a sudden gaining electrons from thin air. Okay, they have to come from somewhere. Just like matter cannot be created or destroyed, energy cannot be created or destroyed, electrons can be neither created nor destroyed. They are conserved. Okay. So that just means that if one substance is going to have a charge, it means it gained some electrons from somewhere, some other object, or it lost electrons to some other object. Okay. So electrons can be transferred from atom to atom or from object to object. You have probably experienced this, okay? When you rub your feet across the carpet, okay, you become charged. You're gaining extra electrons from that carpet, so you are now carrying a charge, and when you go and touch the doorknob or you touch someone else, those electrons are transferred again in the form of a little shock. Static electricity, we call it.